A black hole. The mass of 20 million suns is crossing intergalactic space right now, and there is no galaxy around it. No stars orbit it. No light escapes it. It produces no signal, emits no radiation, leaves no trace on any telescope pointed in its direction. The textbook said this could happen. Physicists predicted it in the 1970s. That prediction sat in the literature for 50 years with 0 confirmed cases. Then, in 2023, a Hubble Space Telescope image caught something that had no precedent. A thin, linear streak extending from a dwarf galaxy into open space. 200,000 light-years long. The team that found it searched the astronomical record for comparable structures. They found none. That is where the story begins. The image looked almost like a mistake. A processing artifact. Something in the optics. The streak was so thin and so geometrically precise that the first instinct was to explain it away. But the team, led by Peter van Dokkum at Yale University, ran the numbers. The light in that streak was real. The gas was real. The stars embedded in it were real. Young stars recently formed, falling within the expected ranges of age, metallicity, and dust content for material disturbed by a massive gravitational object roughly 39 million years ago. Something had passed through that region. Something enormous. And it was no longer there. The simplest explanation exists. It has always existed. When two galaxies merge, their central black holes eventually spiral toward the new gravitational core. That process takes hundreds of millions of years, sometimes billions, as the two black holes shed energy through their interaction with surrounding stars and gas. But occasionally, a third black hole enters the system. A second merger brings a new participant into the gravitational dance, and 3 massive black holes in close proximity produce an unstable configuration. The physics is well established. 2 of the 3 lock into a tighter orbit. The third gets flung outward. Not slowly, not gradually. With a velocity kick large enough to overcome the gravitational pull of an entire galaxy. That is version 1. The expected answer. Confirmed by theory, consistent with the observation, satisfying in its structure. Except the scale refused to behave. The wake behind this object, the scar it left in the circumgalactic gas as it pushed through, stretches 200,000 light-years. To put that in a frame that matters, the Milky Way galaxy, from edge to edge, is roughly 100,000 light-years across. The scar left by this black hole is twice as long as our entire galaxy is wide. Whatever made that mark was moving fast enough, and with enough mass to compress and heat gas across a region larger than the place we live, and then keep going. The textbook answer explains the ejection. It does not explain why that scale should feel manageable. The James Webb Space Telescope confirmed the case in December 2025. Van Dokkum's team returned to the object, now named RBH-1, with JWST's NIRSpec instrument, which captures both images and spectra simultaneously across a small patch of sky. What they found at the leading tip of the streak was a bow shock, a compressed, heated wall of gas piling up in front of an object moving supersonically through the circumgalactic medium. The velocity gradient measured at that bow shock was 600 kilometers per second across a single kiloparsec. That is a sudden, localized change in speed that can only come from something massive moving faster than the local speed of sound in that gas. The final velocity estimate, approximately 1,000 kilometers per second, 3,000 times the speed of sound at sea level on Earth. RBH-1 is moving at 3,000 times the speed of sound through intergalactic space with 20 million solar masses behind it and no galaxy around it. Sagittarius A The supermassive black hole at the center of the Milky Way has a mass of 4 million suns. RBH1 is 5 times more massive than the black hole our entire galaxy orbits, and it is moving through empty space, attached to nothing, bound by nothing, slowing for nothing. The gravitational slingshot explains how it left. That explanation is solid. The authors write that the evidence confirms a long-predicted consequence of gravitational wave recoil or multi-body ejection from galactic nuclei. The paper uses the phrase bordering on overwhelming to describe the evidence for the BUW shock. So version 1 closes the mechanism. Galaxy merged. 3 black holes. 1 got flung. But version 1 is not the disturbing part. Here is the thing that version 1 leaves completely open. RBH1 was found by accident. It was crossing through a region dense enough in gas to leave a visible scar. In that gas, it compressed material. It triggered star formation. It created a wake that glowed in the ultraviolet and infrared long enough for a Hubble survey to accidentally capture a thin, bright line in a processed image. If RBH1 had been crossing through a region of empty intergalactic space, the vast, nearly baryon-free voids that make up most of the universe's volume, there would be nothing. No wake, no streak, no bow shock bright enough to see, no stars, no signal, complete invisibility. We only found it because it hit something. That is not a secondary detail. That is the entire structure of the problem. A black hole, the mass of 20 million suns, moving at 3,000 times the speed of sound, is only detectable to us when it happens to interact with material dense enough to glow. In the silence between galaxies, stripped of that interaction, it would pass through the observable universe without leaving a single feature on any instrument we have. This raises a question that the discovery of RBH1 does not answer. It opens it wider. How many haven't made that kind of mess? In 2021, a simulation called Romulus, a cosmological model calibrated against observed galaxy properties, produced an uncomfortable result. In a galaxy the mass of the Milky Way, at any given time in the current epoch of the universe, Romulus predicts an average of 12 wandering supermassive black holes distributed through the outer halo, not passing through, not briefly visiting, orbiting in the halo, far from the galactic center, having arrived aboard satellite galaxies that merged with the Milky Way at various points across billions of years of cosmic history. Each merger that the Milky Way has experienced, and it has experienced many, potentially deposited at least one massive black hole into the outer regions of our galactic system. 12. In the Milky Way halo, right now, according to the simulation, none of them detected. The simulation result was published in the monthly notices of the Royal Astronomical Society. It is not a fringe claim. The researchers noted their next steps were to identify possible observational signatures for these wandering giants, hallmarks that might eventually allow direct detection. They published that intention in 2021. The first confirmed detection of a runaway supermassive black hole via its bow shock came 4 years later, in a galaxy 7.5 billion light-years away. The Milky Way's predicted 12 remain uncounted. This is not a conspiracy. There is no hidden data, no suppressed report, no agency sitting on an observation that would answer the question. The gap is technical. The instruments needed to find a dormant black hole drifting through an empty halo do not yet exist in the form required. What does exist is the simulation, the prediction, and the confirmed existence of at least one confirmed rogue in a distant system, proof that the mechanism is real. Version 2, then, is not a dramatic alternative explanation. It is the population problem. RBH1 is the only one we found because it was the only one loud enough to hear. The 12 in the Milky Way halo if they exist as the models suggest, are silent. And silence, in this context, means something specific. It means the instruments register nothing. It does not mean nothing is there. 200,000 light-years of scar tissue drifting through space, and it took a lucky angle on a Hubble survey image to find it. That is the first case. The second case is different, and in some ways more unsettling, because the method of discovery it required was not a scar, it was a death. In 2024, the Zwicky Transient Facility at Palomar Observatory, a wide-field survey camera designed to catch things that change, flagged an anomalous burst of radiation in a galaxy approximately 600 million light-years from Earth. The burst had the signature of a tidal disruption event. A star had wandered too close to a supermassive black hole and been torn apart. The black hole's tidal forces, the difference in gravitational pull across the diameter of the star, exceeded the star's own structural integrity. The star was shredded. Its material formed a brief, intensely bright accretion disk, radiating across X-ray and ultraviolet wavelengths as the debris spiraled inward. Tidal disruption events are known. They are catalogued. Astronomers have detected many of them, and they nearly always occur at the centers of galaxies, because that is where supermassive black holes are supposed to live. This one did not occur at the center. Hubble and Chandra were pointed at the source. Hubble captured the ultraviolet flash, a small, isolated blue-white point of light in the optical image of an orange elliptical galaxy. Chandra confirmed the X-ray emission surrounding the event. Both instruments independently measured the same thing. The position of the tidal disruption was offset from the galactic nucleus by approximately 2,600 light-years. The event was named AT 2024 TVD. The paper was published by Yuhan Yao and colleagues at UC Berkeley in a 2025 issue of the Astrophysical Journal Letters, with a formal NASA and ESA release on May 8th of that year. 2,600 light-years from the center. For scale, the distance from Earth to Sagittarius A, the black hole at the center of our own galaxy, is approximately 26,000 light-years. AT 2024 TVD's rogue black hole was offset by 1/10 of that distance, close to its galactic center in relative terms, but far enough that it should not be there. Supermassive black holes at galactic centers are anchored by the gravitational well of the galaxy itself, by the dense stellar bulge, by hundreds of millions of years of slow orbital decay that draws them toward the deepest point of the potential. A black hole 2,600 light-years off-center is not in the center. It is wandering. The galaxy showed evidence of a past merger. A second, larger black hole sat at the actual nucleus, likely many times more massive than the wandering one. The most probable explanation, according to the authors, is that AT 2024 TVD's black hole is a leftover, carried in by a smaller galaxy that was absorbed at some point in the system's history, deposited off-center, and never fully drawn to the middle. Caught in a slow drift, orbiting loosely, waiting, until a star happened to pass close enough. That is how we found it. A star, in the wrong place at the wrong time, drifting too close to a black hole that had no business being where it was. The star died. The flash lasted long enough to be detected. And for the first time, astronomers had direct observational confirmation of a rogue supermassive black hole caught in the act of existing somewhere it should not be. Version 3 is now in full view, and the horror of it is not dramatic. It is structural. Both confirmed detections of rogue, or wandering supermassive black holes, required an accident. RBH1 required a gas cloud dense enough to produce a 200,000 light-year luminous wake. AT 2024 TVD required a star to cross the black hole's path at just the right proximity. Remove the gas cloud, remove the star, and both black holes are invisible. Not difficult to detect, not faint and requiring better instruments. Invisible in the strict sense, producing no photons, no radio emission, no infrared glow, no gravitational wave signal detectable by current technology. A rogue supermassive black hole drifting through empty halo space is, by every measure available to current astronomy, indistinguishable from nothing. This is not a gap in publicly available data. It is not a delayed report. There is no missing transcript. The detection limit is honest, acknowledged in the literature, and unresolved not because anyone is withholding a method, but because the method does not yet exist. You are sitting on a planet inside a galaxy that, according to one of the most carefully calibrated simulations of galaxy formation available, likely hosts approximately 12 wandering supermassive black holes in its outer halo. Those black holes arrived with the satellite galaxies the Milky Way has consumed across its lifetime. The Milky Way has been a cannibal. It has absorbed dozens of smaller systems. Each of those systems may have brought its own central black hole. And some of those black holes never completed the inward journey to the galactic nucleus. They stalled. They drifted. They continue to orbit, somewhere in the dark beyond the visible disk, at distances that could range from tens of thousands to hundreds of thousands of light years from where you are sitting. None of them has eaten a star in front of a telescope yet. Or if one has, we have not recognized what we were looking at. The Romulus prediction is a simulation result, not an observation. It should be held with appropriate uncertainty. Simulations can be wrong. The number 12 is a model output, not a census. But the simulation was not constructed to predict rogue black holes. It was built to model galaxy formation broadly, and the wandering black holes emerged from it as a consequence of the merger histories it tracked. They were not put in by hand. They were a result, and the mechanism that produces them is now confirmed. In a galaxy 7.5 billion light-years away, by a bow shock measured by the James Webb Space Telescope. This is where version 4 enters, and it is the one that extends furthest beyond the current moment. If any of the Milky Way's predicted wandering black holes were to drift close enough to Sagittarius A star at the galactic center, the gravitational interaction would eventually, over timescales of billions of years, draw the two objects toward merger. A merger between two supermassive black holes releases gravitational waves. Not the kind detected by ground-based observatories like LIGO, which are sensitive to stellar mass black hole mergers in the range of tens to hundreds of solar masses. Supermassive black hole mergers produce gravitational waves at lower frequencies, longer wavelengths, waves that ripple through space-time on scales that require a detector the size of a significant fraction of the inner solar system to measure. That detector is called LISA, the Laser Interferometer Space Antenna, a joint ESA and NASA mission currently planned for launch in the 2030s. 3 spacecraft, separated by millions of kilometers, connected by laser beams, designed specifically to detect gravitational waves from merging supermassive black holes across cosmological distances. LISA will, for the first time, give astronomy a way to hear these events directly. But LISA hears the collision. It does not see the approach. The wandering black hole heading toward a merger is silent right up until the moment of coalescence begins. There is no warning signal, no electromagnetic precursor from empty space. The event LISA is built to detect is the endpoint of a process that could be unfolding invisibly right now in any galaxy in the local universe, including this one. "It boggles the mind," Van Dockum told Space.com after the JWST confirmation of RBH1. He was referring to the forces required to dislodge an object of 20 million solar masses from its home. The forces that did it, a three-body gravitational interaction, or a recoil kick from a gravitational wave burst during merger, are not exotic. They are a natural consequence of galaxy evolution. Galaxies merge. This is normal. This is the future of the Milky Way, which will collide with the Andromeda Galaxy in roughly 4 billion years. Two central black holes will eventually spiral toward each other in the new merged system. What happens to the others, the wanderers already in the halo, the deposits from old satellite mergers, is an open question. The Hubble image of AT24TVD sits in the public record, released May 8, 2025. An orange elliptical galaxy, softly glowing, unremarkable in shape, and offset from its center, not at the nucleus, but to one side, a small blue-white point, ultraviolet light, a star being consumed. The black hole responsible was not visible before that star wandered close. It will not be visible again after the accretion disk fades. The event will end, the flash will dim, and the black hole will continue on its path through that galaxy, invisible, waiting for the next accident. That is the case as it stands. Two confirmed detections, both requiring the black hole to destroy something to announce itself. A simulation predicting 12 silent counterparts in the structure of our own galaxy. A planned instrument that will detect their eventual collisions decades from now. And a 50-year-old theoretical prediction, quietly sitting in the literature, now confirmed not by a dedicated search, but by a streak in a survey image that someone almost explained away. The wake behind RBH1 is 200,000 light-years long. It is longer than the Milky Way. The object that made it left no forwarding address. It is still out there, still moving at 3,000 times the speed of sound, now beyond even the gas cloud that briefly made it visible. Ahead of it, nothing detectable. No density, no gas, no stars to eat, no material to compress.